At its core, 3D modeling and animation packages will work with three basic components to create pretty much any kind of model that we see on screen. These three elements are vertices, edges, and polygons. And there are some different classes of each of those, but we're going to have a quick look here at each of those in a little bit of detail so you can understand their place for creating balanced 3D models. Let's start by looking at the vertex. Now, a vertex in some ways can equate to a pixel in a 2D application, but the big difference is that a pixel is really the basic element that you actually see on screen with a 2D image. So if you take a Photoshop image and you increase the size and you blow it up, you'll see a really big pixel in the middle of your screen, right? But with a vertex, really all it is a visual representation of a set of coordinates. In this case, we have a single vertex here, which you can see in all of the views here. Now I've got it selected so it's highlighted in orange. And this vertex is right at the origin, or the center of space, where the x, y, and z coordinates are all 0. So this is at 0, 0, 0. And you can actually see on my properties on the right-hand side that we are at position 0, 0, 0. So as I mentioned, unlike a pixel, this isn't something that we're actually going to see, and since it's only a representation of a point in space, if I zoom in on it, you can see it doesn't get any bigger. It just stays the same relative size on screen, and you can actually change the size of the redraw on screen. If you would like to make vertices larger or smaller, you can do that. For the most part, the default size is pretty good, though, because it will allow us to see them without them being too intrusive. All right, so as I mentioned, without anything else, vertices are not going to do anything. But when we start combining them into edges and into polygons, we actually start to be able to build models. So let's move on and look at an edge. So this is actually a couple of series of edges. So on the bottom, we can see a basic construction of edges. We have 4 vertices that are being connected to create 3 continuous edges. If I take any individual vertex and move it, you'll see that we get a straight line between that vertex and the next one. And I can move it in any position in space, and there's still going to be just a straight line that connects those 2 points. This is the kind of edge that we'll use with most of our modeling constructions. Now, the set of edges up above, well, right now it looks almost identical to what's underneath. It's still 4 vertices and 3 edges being connected. These are actually connected together to create a curve. So if I take one individual point, I'm going to take one in the middle here, and I move it, you'll see that not only do we not just get a straight line between this edge and the edges on either side, but also that the curve continues to deform past the edge on the left, and the edge that's created between the first and second vertices is also moving as the curve tries to create one continuous flow between all 4 of these points. Now, we'll use curves in some of our modeling application later on, but for creating actual polygons, we'll actually just be using the lower version here that's just linear points connected to each other. Moving on, we can see polygons, all right? And here we have 2 separate polygons, and one is actually a polygon that is divided into 2 triangles. So you can see here's one triangle and a second triangle, and they're still just making up one piece. Now on the right, we have a 4-sided polygon, which is often called a quad, and this will be the kind of polygons that we really kind of strive to get whenever we're creating 3D models, because the flow of polygons, if you're using 4-sided polygons, will be much easier to edit, to animate, and also to adjust later on. So we want to make sure that we'll try to keep 4-sided polygons, but as far as our graphics card is considered on the computer, it breaks everything down into triangles anyway. So if you take an individual vertex here, and I'm just going to take this one and move it up, you'll see that we have this point here is now connecting to these 2 points down there, and we get a triangle connecting those 3 pieces. The same thing down here, we have a flat triangle connecting those pieces. Now, if we try to do this same thing with the 4-sided polygon, what happens is we actually get a bit of visual ambiguity. And since there is no edge that connects anything across the middle of these vertices, the graphics card just has to kind of pick a lane, redraw it as triangles, and in this case we actually see an edge going down through the middle, connecting this point to the other one, but it could also be connected the way that this one is connected. The problem is that ambiguity. Now, this will not be an issue with most times that we're using polygons, as for the most part they will be relatively flat, and you'll see as we get modeling some things in a later chapter. But this is why it's important to know. If we even look down here in the bottom right-hand corner of this view, we see that it says GL4, and that just means that there are 4 polygons that the graphics card has to redraw in order to create this scene here, this simple scene. So there's 2 here on the left, and it's the one that's flat and the one that's diagonally up, and there's 2 on the right, and what it's essentially doing is it's taking one on the right and it's connecting the side point to the 2 in the middle, and then there's another one that's creating the other side to the 2 in the middle. But since we don't have an edge there already, the graphics card has to just kind of interpolate and figure out the best way for it to do that. All right, so moving on, we have one last type of structure to look at, and that is a subdivision surface. Now, you can kind of think about this in a real simple way, like the difference between the edge and the curve, in that it is not going to give us a straight line interpolation, but it's going to give us a smooth interpolation between all of the existing points. So you can see here, even though I only have 1, 2, 3 4-sided polygons, my OpenGL count down here on the right-hand side is 384. That's because this has been subdivided in order to create a smooth surface, which right now you won't notice, but if I move this point up, or this edge up, you'll see that now we have this nice, smooth, curving surface that goes along between all of the points. Now, the interpolation that's used in subdivision surfaces is a little bit different than the one in curves. If we look at the lower left-hand view here, you can see that we don't get that arc from the first point to the second point as we did with the curve, but we do get a nice smooth interpolation from 1, 2, 3, and 4 edges to create a nice smooth surface. Now, using vertices, edges, polygons, and eventually subdivision surfaces, we can create and edit pretty much anything that we'll use inside of a 3D application and inside of Modo to create complex models of really any type.